Hello everyone, I am Paramita Dutta of University of Florida-EEE department, and my project is on performance of adaptive median filter on salt and pepper noise. The different contents which I will go through in my presentation are introduction, the types of noises, linear and non-linear filtering, types of filter, adaptive median filter, simulation and experimental results, related works, conclusion, acknowledgement and references. Image processing is one of the rapidly and fast-growing technology in computer science and engineering domain. The growth of this field has been expedited by the technological advances in digital computing, computer processors, digital signal processing, and the mass storage devices. Noise is a random variation of image intensity and is always present in digital signal during image acquisition, coding, transmission, and processing steps. It means pixels within the picture present different intensity values rather than the correct pixel values. Noise produces undesirable effects such as artifacts and realistic edges, unseen lines, corners, blurred objects, and disturbs background scenes. The image denoising is thus an equally important task in image processing for the analysis of images. The primary objective is image restoration is to remove the noise from the image in a manner that the original image is discernible. The different types of noises are the photoelectronic noise, impulse noise, structured noise, white noise, Brownian noise, gamma noise, periodic noise, quantization noise, and the Rayleigh noise. In my project, I will mainly focus on the impulse noise. Now, impulse noise can be broadly classified into two groups, the salt and pepper noise and the random valued impulse noise. In this project, my focus will be primarily on the salt and pepper noise. Now, salt and pepper noise changes the pixel values either to the maximum or to the minimum pixel restoration and occurs when the sensing element gets completely damaged. The other type of noise, the random valued impulse noise, is that which alters the pixel values randomly between the minimum and the maximum range. The other different types of impulse noises are the Gaussian noise, the Poisson noise, and the speckle noise. Now, the Gaussian noise is the noise which remains evenly distributed over the entire image signal, and thereby each pixel in the noisy image is the sum of the true pixel values and a random Gaussian distribution noise value. The noise is independent of intensity of pixel value at each point. Now, Poisson noise is caused when the number of photons sensed by the sensor is not sufficient to provide detectable statistical information. Now, this noise exists because of phenomena like the light and electric current that consist of the movement of discrete packets, and its magnitude increases with the average magnitude of the current on light intensity. The speckle noise is commonly observed in radar sensing system, although it may appear in any other remotely sensed image utilizing coherent radiation. Now, I have produced the different types of impulse noises. The first image is my image which is corrupted with the salt and pepper type of noise. The second image is corrupted with a Gaussian noise, the third is corrupted with a speckle noise, and the fourth is corrupted with a Poisson noise. Now, to remove noise, different filtering techniques are required. Now, linear and nonlinear filtering techniques are two of the filtering techniques, and these are used to remove unwanted noise. Now, the linear filtering technique is the technique which removes noise by convolving the original image with a mask that represents a low-pass filter or smoothing operation. Although linear methods are fast, they do not preserve the details of the image. Now, so we use a non-linear filtering method. In the non-linear filtering technique, it's a two-phase filtering process. In the first phase, the pixels are identified as corrupted or uncorrupted pixel, and in the second phase, the corrupted pixel is filtered using the specified algorithm while the uncorrupted pixel value is retained. It is a filter whose output is not a linear function of its input. In this project, I am using a non-linear filtering method for better preservation of the details of my image. Now this is the block diagram of this non-linear filtering technique I just spoke about, which involves an impulse detector, a filtering method with a median filter, and in the output we get a filtered image. The different types of filters that are used for linear and non-linear filtering techniques are the mean filter, the median filter, the adaptive filter, the Wiener filter, and the max and mean filter. In this project, I am using how the adaptive median filter is used for getting a very good quality image after removing the noise from it. In this adaptive median filter is designed to eliminate the problems which are faced by a standard median filter. The adaptive median filter changes its behavior based on the statistical characteristics of the image inside the filter window, and it helps to smoothen out other types of noise and gives much superior performance compared to a non-adaptive counterpart. The mean and variances are the two important statistical measures which are based on the adaptive filters, and the adaptive median filter achieves a good result in most cases at the cost of added filter complexity, but even so, computation time is proportional to the degree of corruption of the image being filtered. Now this is the flow chart of the algorithm I have used in my simulation. First it reads the image, then declare its maximum allowable size of a window, which can be say S max. Then it calculates the minimum, maximum and the median value in the neighborhood. A comparison is done between the median, maximum and the mean minimum, and if it satisfies the comparison, then it goes ahead and compares the pixel value with the minimum and maximum in the neighborhood. If it is not satisfied, it goes ahead and increases the window size by 2, and then checks if the window size is less than the maximum allowable size. If it is less than the maximum allowable size, it goes back to the comparison of the minimum, maximum and the median. In case the pixel under consideration is less than the maximum and greater than the minimum, then the output is unchanged. If it is not, then the output is replaced by the median value, and at the end the filtered image is displayed. Now this is the different peak signal to noise ratio values that I have calculated for different noise densities with my image, and these are the values that I got for the median filter 3x3 window, median filtering 5x5 window, and using adaptive median filtering. Now as we know that the better value of PSNR denotes that it is a better filtering method, and in this case we found a very good result for the adaptive median filter, and so we can say that the adaptive median filter is much better than the 3x3 window and the 5x5 window of the median filtering method. Now this is the chart which I have plotted with the values of the PSNR values that I got from the previous results. After running my code, this is the final simulation result that I got, and I have plotted it with the different like the original image, the image with salt and pepper noise, the grayscale image after removing the salt and pepper noise with standard median filtering, 3x3 window, 5x5 window, and finally using the adaptive median filtering method to remove the salt and pepper noise from my image. And as we can see that with the adaptive median filtering, the removal of the noise is the best. The different related work that I chanced upon are the center weighted median filter, progressive switching median filter, adaptive progressive switching median filter, tri-state median filter. Two of the currently best known nonlinear filtering techniques are the conventional adaptive filtering techniques and decision-based median filtering techniques. Currently, a new decision-based median filter, adaptive decision-based median filter, has been proposed. A brief overview is given for the different types of noises and the different filters used for image denoising. Adaptive median filter plays a pivotal role in image processing and is the most efficient in removing the salt and pepper noise, which is a kind of impulse noise and which I have focused in my project. This project details with the implementation of this adaptive median filter in MATLAB and the removal of the salt and pepper noise from this image using this adaptive median filter. Lastly, I would like to thank my professor Dr. Dapeng Wu at University of Florida for his immense support, cooperation and invaluable inputs throughout the completion of my project. I would also like to acknowledge the authors of the work that I have referenced for the project. The methodologies in the references has been of tremendous help during the course of this project. These are the different references I have used for the compilation of my project. Now I would like to go through my code to show the simulation and the results. This is the adaptive median filtering code which I am using, and as you can see, I have taken my image as the input image for this code, and I am using converting it into a gray image. Secondly, I am incorporating a 25% salt and pepper noise into my image, and then I am using a median filter 3x3 and median filter 5x5 to remove this noise. Finally, I am incorporating the algorithm I have discussed in the flow chart for the adaptive median filter. Here it compares between the minimum, maximum and the median, and then either the value of the pixel is unchanged or it is replaced by the median value. Now I will run my code to show you the result of my simulation. The adaptive median filter is taking a little bit time to process. Finally, the results are: the first image is my original image, the second image is the image which is corrupted with 25% salt and pepper noise, the third is using a median filter. I am removing the noise, a 3x3 window. The fourth is the median. After using the median filter 5x5 window, I am getting a better result, but the image as we see is blurred. Now the final image is using the adaptive median filter. I am removing the salt and pepper noise. Here we can see that the result is the best result, and also the edge correction is perfect. This is the end of my presentation. Thank you.